Hi everyone. In this video we're going to discuss how to graph rational functions. In front of you are pretty much the steps to guarantee that you actually graph one of these correctly. The first step, you always got to simplify by factoring. Now once you find the factors of your equation, you then want to find your domain. The reason why you also want to do this is because in case you are able to cancel something out, you want to cancel it out. The next step, you want to be able to find your y-intercept, and you got to remember, to find your y-intercept you always plug in 0 into x. Third step, you have to find your x-intercept, which means that you have to plug 0 into y. Anytime you have to find x and y-intercept, you always plug in 0 into the opposite one. Or, if you just have one fraction, then you're going to set the top equal to 0, which we'll go over in a little bit. Your fourth step is to find VAs and HAs, which are your vertical asymptotes and horizontal asymptotes, and your last step is you need to find other points around your VA. So we'll go ahead and get started. So your first equation that we're going to have is x over x squared minus 9. Now if we look at step 1 said that we have to be able to factor this out. Now this is going to factor out to give you x over x minus 3, x plus 3. Now the reason why you want to actually factor it out is because sometimes you're going to get the opportunity to cancel out the numerator with the denominator if they have the same exact factor. But in this case I can't cancel anything out. So I'm going to go ahead and find my domain. The way I find my domain is I want to set the bottom equal to 0. So I'm going to set the bottom equal to 0. X minus 3 equals to 0, as well as x plus 3 equals to 0. I solve for x is equal to 3, x is equal to negative 3. Now the unique thing about domain is these are the values that it cannot be. Anytime you set the bottom equal to 0, you're trying to find undefined points because you can never have 0 in your denominator. So then once you find these values, your domain is going to be negative infinity to negative 3, union negative 3 to 3, union 3 to infinity. The reason why negative 3 comes first is because that's the number that goes on your number line. Now your next step is to find y-intercept. Well, for the y-intercept you're plugging 0 into x's, so I'm going to go ahead and do that. 0 over 0 squared minus 9. Work that out, that gives you 0 over negative 9, which gives you 0. So your y-intercept is at 0. Then you're going to go ahead and find the x-intercept. And to find the x-intercept, you're technically plugging in 0 into y. But because I have one equation, the shortcut to this is just set the top x equal to 0 and solve for it. In this case, it's already factored, and you don't have to do anything else, so then x equals 0 is your x-intercept. Your next step is, well, let's find your vertical asymptotes. Well, to find vertical asymptotes, you're going to set the bottom equal to 0. Those, and which we already did because that's those same points as your domain. So when we set the bottom equal to 0, we got x equals to 3 and negative 3. And those are your vertical asymptotes. And your last step is, well, let's find HA. Now HA is looking at your rules. If you notice, your top degree is a 1 and your bottom degree is a 2. When your top degree is less than your bottom degree, that means that your horizontal asymptote is going to be at y equals to 0. And then there's no holes in this equation because nothing canceled out. So once you find all this, all we're going to do is we're actually going to graph everything. We're going to graph everything we found. So I always start off with always drawing your horizontal asymptote. Now to draw your horizontal asymptote, I already know at y equals 0, horizontal asymptote goes side to side at y equals to 0. Then I'm going to draw my vertical asymptotes, one at 3 and the other one's at negative 3. Now, next step is graph any points that you found. Well, you found an x-intercept at 0 and a y-intercept at 0, so unfortunately all we have is 1 point. Now, the part that's a little confusing is we don't know what happens on this side of the graph. We have no idea. So what we need to do is we need to find points, and that's where step 5 comes in. Find points around your vertical asymptote. So for every single vertical asymptote that you have, what you're going to do is an x and y table. Now, the reason why I draw an x and y table like this is so that you can actually find points left and right of your vertical asymptote. So I'll put my vertical asymptote here, and I know it can't be any points because that makes it undefined, so I'll just put a little slash here. Then I'll pick a point left of it, negative 4, pick a point right of it, negative 2. Now we're going to plug these points into our original equation. And when we plug in our points into our original equation, remember your original equation was the x over x squared minus 9, you're going to get negative 0.57, and when you plug in negative 2, you're going to get 0.4. Now negative 4, that's here, negative 0.57, somewhere between 0 and negative 1, somewhere here at 2.4. Then you can do the same exact thing around the other vertical asymptote. X, Y, put your vertical asymptote in the middle. Remember, you can't get a point. 2, 4. And you're going to do the same exact thing. Plug in points, you'll get negative 0.4, 4, 0.57. Now, these points don't always match up with the other points. This just happens to be a coincidence. So now, plug these points in. 2, negative 0.4, 4, 0.57. Now, this is when you're pretty much playing connect the dots. The second you have one point on the bottom of this graph, you know your shape is going to look like this. Every single time. The reason why it's going to look like that is because it can't cross this horizontal asymptote or this vertical asymptote. So it kind of have to follow this. It has to follow the shape, follow the asymptotes. This corner is always going to match up with that corner where it crosses the asymptotes. Now in the middle is the confusing part. The middle, you're either going to have a snake or a parabola. So since I know if I play connect the dots, I have a point here, it has to cross this point to the next point and come here, I know I'm going to have a snake as a graph. And then lastly on the other side, well, since I already have a point here, I already know my graph is going to be up here to create this sideways U shape. And that's how you graph this shape. Okay? So the one in the middle, you're always going to have either a snake or a parabola. But you always want to pick points left and right of your vertical asymptote of each one so that you can see where your points are going to be, either on the top or on the bottom. Okay, so let's try another one. X squared minus 16 over x squared plus 2x minus 24. So same exact thing you did on the other one, you got to factor it out. So I'm going to go ahead and factor this out. Difference in squares on the top, x minus 4, x plus 4. Factor out the bottom, x plus 6, x minus 4. Now you'll notice something. Hopefully you'll notice that they both have an x minus 4 on top and bottom. What that means is there's going to be a hole. So you're going to cross those out, and your new equation is going to be x plus 4 over x plus 6. So everything we do from here on out is going to be with that new equation. So step 1 said factor it out and then find your domain. Well, your domain, you're going to use your original equation. Only for your domain though. So your domain, you're going to set the bottom equal to 0, x plus 6 equals to 0, x minus 4 equals to 0. Solve for, you get x cannot equal to negative 6, and x cannot equal to 4. So your domain is going to be negative infinity to the first point, which is negative 6, union negative 6 to the next point, union 4 to infinity. Now step 2 was find your y-intercept. Now remember, finding y-intercept, we're plugging 0 into our new equation. 0 plus 4 over 0 plus 6 is going to give you 4 over 6, which then gives you to 0.67. I always change everything to decimals because since we're going to graph everything, you always want a real number. Step 3, find x-intercept. Now remember, x-intercept, since you only have one fraction, set the top equal to 0. X plus 4 equals to 0, x equals to negative 4. Then find your VAs. Now remember, to find your VAs, you're always going to set the new equation equal to 0, the bottom. You're going to get x plus 6 cannot equal to 0. X equals to 6 to negative 6 is your vertical asymptote. To find your HA, you're going to look at your degrees. Well, if you notice, your degree on top is a 1 and your degree on the bottom is also a 1. So because your degrees are equal to each other, you're going to divide the leading coefficients, the leading numbers. You have a 1 over a 1, which means your horizontal asymptote is going to be y equals to 1. You always divide them when the degrees are equal to each other. Now the next step is, are there any holes? Now remember, we crossed them out, so that means that there's going to be a hole. So to actually find the hole, you're going to set the one you canceled out equal to 0 and solve for that. Only to the one you crossed out. X equals to 4. That means you have a hole at x equals 4. Now because you have a hole at x equals 4, what we're going to do is we're actually going to plug this hole, this 4, into our new equation. So we're going to plug into our new equation, so you're going to get 4 plus 4 over 4 plus 6, which is going to equal 8 over 10, which is equal to 0.8. So that means that we have a hole at 4 comma 0.8. Now your next step, after you do all of this stuff, after you do everything that you have here, what we're going to do is we're going to actually go about this by graphing everything we found. So this is where I'm going to go to the new sheet. You're going to graph everything you found. So everything from your HAs, well, you already know you have an HA at y equals to 1. You already know you have a vertical asymptote at x cannot equal -6. You have an x-intercept at -4. You have a y-intercept at 0.67. And you have a hole at 4 comma 0.8. Now a hole is literally a hole. You literally have to do an open circle anytime you have to graph a hole. Now your next step is, well, because I don't really have points, I want to set up my chart. X, Y, plug your vertical asymptote in the middle, -6, pick a point left and right. If you pick a point left of it, you get -7. Pick a point right of it, you get -5. And you're going to plug these points, -7, -6, -7, -5, into your new equation. So new equation was x plus 4 over x plus 6. So if you plug this in, you're going to get -7 over plus 4. Which ends up giving you 3. So at -7 you have 3. Now, I could plug in -5 into my equation. I could. And I'll plug it in just to show you. -5 plus 4 over -5 plus 6 is going to give you -1 over 1, which gives you -1. That means at -5, you're going all the way down to -1. Now, I actually didn't have to plug in -5 because I already had more than enough points to graph this. So when I graph the right side, I know it's going to just look like this. And I can't put a line through this hole because there's never going to be a point at a hole. Now on the left-hand side, since I have a point on top, I absolutely know that my graph has to look like this. And that's how you graph a rational equation with a hole. All you need to do is do your steps, then set up a table with the vertical asymptote in the middle, pick a point left, pick a point right, and graph everything you found and just play connect the dots. Okay? Hope this helped. Thanks for watching.